This is lesson 3.8b, variables on both sides. This is day 2. We're in your notes packet on pages 16 and 17. So we're going to see a little bit more intense, I would say, equations today, and we're going to have to follow the steps that are on the phone here. So we're going to start off if we see any distributing and then combine our like terms if necessary, move the variable since we have variables on both sides. Remember, we're moving the smaller variable unless there's a variable on one side and there's no other constants over there. And then once we get it down to a two-step equation, we just add or subtract and then multiply or divide. So starting with example number 1, I do see distributive properties. So I'm going to go ahead and start here. 3 times 2x will give me 6x plus 18. And then on this other side, I do see combining like terms here. So I'm going to go ahead and combine them just to take care of one step here. So I have a negative 2x and a 6x, which goes together to give me 4x and plus a 10. So from here, I'm moving the smaller variable, which would be the 4x. I'm going to subtract 4x on both sides. 6x minus 4x is 2x plus 18. The 4x's here cancel, leave me with 10. I'm going to go ahead, add and subtract now, subtract away that 18. So I have 2x is equal to a negative 8. Dividing through by 2 on both sides, I get that x is equal to a negative 4. Over here in example number 2, go ahead and distribute. So I get 2 plus 12x is equal to negative 18 plus 7x. So 7x is the smaller. I'm going to subtract my 7x on both sides. And I'm going to get negative 18. Over here I have 2 plus 5x. Subtract the 2. So I have 5x is equal to a negative 20. Divide through by 5. And we get x is equal to negative 4. In example number 3, I'm going to have you go ahead, distribute this negative 2, move your variable, and solve for x. So you'll write in your answer x equals and then your number. Distributing your negative 2, you get negative 2x minus 8 is equal to x minus 9. We're going to move the negative 2x because it's smaller. So we add 2x to both sides. So we get negative 8 is equal to 3x minus a 9. So we're going to go ahead and add 9. And we get 3x is equal to 1. We're still going to divide through by 3. And it looks like here we're actually going to have a fraction answer, 1/3 for x. Example number 4, I'm going to have you go ahead, distribute on both sides, move your variable, and then add, subtract, multiply, divide. So in distributing my 2, I'm going to get 10x minus 2. And on the right side, I'm going to get 3x plus 33. My smaller is the 3x, so I'm going to move that one. So I have 7x minus 2 is equal to 33. Add 2 on both sides. And I get 7x is equal to 35. Divide through by 7, we get x is equal to 5. Example number 5, I'm going to have you combine your like terms over here, move your variable, and then solve. Combining the 3x and the negative 5x, I get negative 2x plus 5, which is equal to 4x minus 7. Adding the 2x to both sides, since that one's a smaller. So we get 5 is equal to 6x minus 7. Adding 7, trying to work to get my variable alone. So I get 6x is equal to 12. Divide through by 6, and I get 2 equals x. In example number 6, this one's a pretty complicated one. There's a lot of steps. So we'll distribute first. 2x minus 10 plus 3x plus 4. And over here, I'm going to go ahead and combine my like terms, a positive 9 and the negative 3, which will give me a positive 6. The 2x and the 3x on the left go together. The negative 10 and the positive 4 give me a negative 6. And this is equal to 8x plus 6. I'm going to subtract away the 5x. So I get negative 6 is equal to 3x plus 6. If I subtract 6 on both sides, I get negative 12 is equal to 3x. Divide through by 3, and I get negative 4 is equal to x for example 6. In example 7, we start off with some word problems. Your science class is doing an experiment. You start with 2 plants. Plant A is 5 centimeters tall and plant B is 8 centimeters tall. Plant A is fertilized and grows 2 centimeters per day. Plant B is not fertilized and grows 1.5 centimeters per day. In how many days will the plants be the same height? So again, we're looking to see when these are equal. Plant A starts off at 5 centimeters, is fertilized and grows 2 centimeters per day. What would the expression be that would represent plant A? Go ahead, type your answer in. So plant A starts at 5 centimeters and grows 2 centimeters per day. So we would have something like 5 plus 2x. Plant B starts off at 8 centimeters tall, is not fertilized, but also grows 1.5 centimeters per day. What is the expression for plant B? Starting at 8, still grows 1.5 per day. We're going to go ahead and set these two equal to each other. So we have 5 plus 2x is equal to 8 plus 1.5x. Move your smaller variable x. So we're going to bring 8. We have 5. 2 minus 1.5 is plus 1/2 x. Subtract away the 5. So 0.5x is equal to 3. Divide by 0.5. We get x is equal to 6. So in 6 days, they will be the same height. Take a look at example number 8. It takes a graphic designer 1.5 hours to make one page on a website. Using a new software, the designer could complete a page in 1.25 hours, but it will take 8 hours to learn. How many pages would the designer have to make to save time using the software? So without the software, it's just 1.5 hours per page. We're going to find out when are these two equal. With the new software, it would be 1.25 hours per page plus the 8 hours of training. So we do have to take that into account. So since this is over here by itself, we want to move obviously this one. It does so work out that it's the smaller one. So over here we're left with 8 is equal to 0.25x. So we'll divide through it by 0.25 on both sides. And we get x is equal to 32. So at 32 pages, the designer is actually going to be equal in terms of time. But it wants to know how many pages would the designer have to make to actually save time using the software. So the designer would need to make 33 pages in order to actually save time. It's not just asking when they're equal this time, but trying to figure out when would they actually start saving time. Example number 9, a gym membership at YMCA charges a $50 sign-up fee and $65 per month. What is your expression to represent the YMCA membership? So $50 sign-up fee and $65 per month, that gets the X. There's a gym membership at Anytime Fitness. We're just going to call this Anytime. And it's a $90 sign-up fee and $45 per month. Go ahead, type in what would your expression be for Anytime Fitness. So they're a $90 sign-up fee and $45 per month X. So for what number of months is the cost of the clubs equal to each other? So we have 50 plus 65x is equal to 90 plus 45x. We're going to go ahead and subtract the smaller variable. So we get 20x plus the 50 is equal to 90. Subtract away the 50, and we get 20x is equal to 40. Dividing through by 20, we get x equals 2 months. So as long as we're at the gym for 2 months, our costs are going to be the same. If we're over 2 months or under 2 months, there's going to be one that would end up being cheaper. Example number 10, I'm going to have you go ahead, set this one up, read it, set it up, solve it, and tell me how long are the length of each wall then for the sections for the plants. So the one wall is a 7-foot storage, and it has 5 sections for the different types of plants. On the opposite wall is a 4-foot storage area and 6 sections. the sections for the plants are equal length. What is the length of the wall? So what we're going to do here is start to solve, subtract our 5x. So we get 7 is equal to 4 plus x. Subtract the 4, and we get 3 equals x. So each section for plants is equal to 3 feet. But that didn't answer the final question because it says how long is the wall. So I could go ahead and take this 3 for x and plug it back into either one of my expressions because the walls are rectangular and they are opposite each other. So they're going to be equal. So I could do 7 plus 5 times 3. So 7 plus 15. So the wall is 22 feet long. And that would actually be my final answer here. That wraps it up for the lesson on variables on both sides.